It's another DSL, exactly. I fully agree with you there.
And
right?
we can talk more about that in the cocktail, but I want to make sure Michael can get to the demo. 'Cause that's what I want to do.
So we know we need something of this nature to kick off the next stage of the process, right? I need to actually get the environment up and running on top of that instance. And even if I pre-stage most of the work, there still is some final configuration. Pass it through Cloud-init, run a tool like this. We're actually going to use Salt because that's actually part of the upstream Kubernetes environment to actually use the Salt stack environment to actually do this final configuration. So Heat will implement our infrastructure, get the right systems model deployed, the right resources implemented into that. In this case, we're going to use Salt to actually get the automation and application up and running, and then we have our environment. So I think this is where we're going to hand over, right? Or was it going to go a little further? Yeah, no, this is you. All right. This is you.
This is all me. No, I don't trust your thing. You keep.
No. Just don't hit that button.
Don't hit that button, other than
which
that
is the one
it
that's
will
right underneath your thumb.
explode.
Right?
So, who actually has been working or playing with, experimenting, learning, is super the deep expert on Kubernetes? All of you, great. So cocktails are early then. So, as Rob mentioned, the automation of the deployment of the Kubernetes cluster in the way the project provides actually the installation mechanism, uses Heat for the infrastructure, deploy the VMs, create the networks and all that, and then Salt stack on top. And so there's a combination of course, well, in this case we're using Docker. It's not exclusive to Docker. It could be Rocket containers. So Kubernetes does not necessarily say, I'm only using this particular type or engine for this. So what is Kubernetes? Let's start there. And Sarah actually this morning did some good, give some good overview. So it originated out of Google based on their experience, based on their, well, it's not entirely, completely 100% based on Borg. It's inspired by, that's how they call it. But it's basically, it's orchestration for containers. So you have a fleet of machines, and Kubernetes helps you to deploy containers, schedule them, run them on those machines, make sure that your application keeps running. Self-healing is a big aspect of that. I'll talk about that in a minute. So, but for containers. There is not just one environment where Kubernetes runs. So we are talking about OpenStack today, but it can run on obviously Google's cloud, AWS, Azure, bare metal. I have a 4-node bare metal cluster at my house, my lab, running. No virtualization over VMs, just Kubernetes cluster right there. Right. So you have options, which is also great because with 1.3, yeah, I think it was 1.3, where the project also introduced federation of clusters so that you can run multiple Kubernetes clusters, and then you can span environments. So that's where it really becomes interesting when we talk about this hybrid cloud thing, right? So let's span multiple environments. So completely open source, as Sarah mentioned this morning. She really is interested in having people join. And the idea basically is to manage applications so that as you deploy a container, you don't need to care or know what is underneath. There's just a fleet of machines that can be bare metal, that can be VMs, but you really don't need to care, nor do you need to know, does this machine have enough capacity for my 20 or 20,000 containers that I want to deploy? Kubernetes takes care of that completely. So what does it do? It does scheduling. So Robert talked about scheduling before. So Kubernetes makes sure that if you say, I have these 20,000 containers, on which machines in your fleet is enough capacity? So you can specify this container needs this amount of CPU capacity, be it a hundredth or a thousandth, or I need a full core or whatever, and it needs that much memory. So now the scheduler can go and most efficiently place these containers on your fleet. So that there's this great demo Kelsey Hightower does with this Tetris emulation, where he has these blocks and they all totally chaos because they are not most optimized for how to be placed. Versus, hey, let me optimize. I have these containers and they need that amount of capacity, both memory and CPU. Where can I place them in the most optimized fashion? So Kubernetes, the scheduler, takes care of that because it knows the status of all the nodes in the cluster and then can basically take care of that. Lifecycle and health. So there is the concept of a replication controller where actually it monitors the containers, and if, let's say, a container dies, it gets automatically restarted. So it's a declarative approach. Hey, I need this number of containers, and it constantly checks it. And then if that is not met, let's say you need 20 and you only have 18, there's automatic reconciliation where it then say, okay, I need 2 more of those, and starts that. Discovery, and where are these? Service discovery, Kubernetes takes care of that, so that containers actually, given that, for example, every container has their own IP address, so every pod, and I talk about what a pod is in a minute. Every pod has their own IP address. Now, given that a pod can die and gets restarted, gets a new IP address, this is not a practical way to address that, right? So Kubernetes has built-in services to make that available. Security, who can do what to containers. The idea of jobs is one where if you have a container that necessarily is not an application that constantly runs, but just you need something that runs and then finishes. And how do you make sure that now this container, this job is done, that it gets cleaned up properly, that it gets killed appropriately, that it gets deleted, and everything gets removed appropriately. So Kubernetes can take that as well. And then scaling up and down. And I will actually show that later in the demo as well. So some of the concepts in Kubernetes. So obviously we have a container. What a surprise. A container orchestration that has containers as a concept. And we have the concept of a pod. And what a pod is basically a collection of containers that somehow are related to one another. It can be a single container. It can be 2 containers that need to be, for example, on the same machine. So if you have 3 containers that are defined as part of a pod, they will always be scheduled on the same node. So they will not span nodes. They always are on the same node. They share the same namespace. They share the same memory. They are basically, a pod is an atomic unit in Kubernetes, and it's a collection of single or multiple. Then we have a service, and the service basically is used to expose over the network this container or this group of containers. So if I, for example, have now 20 containers and their IP addresses constantly change, I can define a service and I can address these pods or these containers through this service. So there is some internal load balancing also built in, so that, again, I don't know what the IP address of that particular container will be at any given point in time, because if it dies, it gets recreated, it has a new one, right? Volume, so speaking of storage, so I can attach a volume to a pod. It can be host mount, it can be an NFS share, so there's that. Labels is a very powerful concept, and this is really on this projector really showing that well. So I can attach labels, multiple labels, to a pod. I can say, this pod is, for example, production, this is test, and then I can specify and I can call when I start them up and say, start up all the production containers or pods. Or give me, this is front end, this is back end, and I can then, or this is for example, staging and production, or version 1, version 2, which then allows me to specify a very select group. I can do rolling upgrades where I say, hey, just roll through at this version and select these labels. I want all these labels. So you can have one label, you can have multiple labels per container or per pod. Replication controller is really, really a great thing. So the replication controller, you specify, I want 20 of these pods. And what the replication controller then does, it just goes out and says, okay, let me start 20 of those. And it constantly keeps checking, do I have 20 of those? And if one disappears, it will start another one to make sure there are constantly 20 of these pods. What I can then also do, and I will show that later, is I can then say, you know what, now I need more than 20, I need 100. I can just scale this up and then it starts it up. I can just redefine, hey, now I need more, it gives me more, I need less, and it automatically does that. So there's self-healing, if you so will, and in that I can say, this is my state, you, Replication Controller, take care of that state. And you take care that this is the case. I don't want to get this call at 3 a.m. in the morning that there's this container that died. Can you just log in and start? There's no point in that, right? So we can automate that. And then finally, the node, which is actually well, it can be a physical machine, it can be a VM where actually all this runs. When we look at the architecture of Kubernetes, so we have an API server, and this is how we interact with the cluster. Either there's the kube control, or some call it kube cuddle. It's a command line tool, or there's a REST API that you can interact with the API server and then basically control this cluster or make calls to a cluster like, hey, I need this, start this pod or start this controller. So all backed out to etcd. So the API server itself is stateless. So everything, all the state about all these pods, about these controls, it's all in etcd. So when we talk about now about the Kubernetes cluster and the deployment thereof, so now I just don't need Kubernetes. I need on top, I need etcd, for example. So the automation takes care of deploying, for example, an etcd cluster as well. Talked about the scheduler. We have the controller manager, which is basically the replication controllers. And then on each node, I have the kubelet, which basically is the thing that starts the pods or kills the pods, and the service proxy. What that is just basically making sure that the service I define, since that's on each node, is reachable over the network. So who wants to demo? Or who wants more power? Who wants more slides? Yeah. Oh, there's 20-something hundred people. So, I mean, in the audience of 2,500 people here in Seattle, that's pretty cool, right? So anyway, so the project. So first of all, you need to get the bits somehow, right? So how do you install Kubernetes? So there is a defined way. So the project actually says, hey, just pull it from here, and you just say, so there's various automation scripts included, as I mentioned before, AWS, Azure, Google Cloud, bare metal. You just specify that, run that one script, and it does it automatically. Unfortunately, it doesn't work for OpenStack yet out of the box. There are some misconfigurations in some of the scripts. So the best way is to just download the release and then make your specific configuration changes. So that requires at least 2 runs, because it will fail the first time you make all the changes, and then it runs, or you just download that way. And that way, and both always pull the latest release. So currently, a couple of days ago, version 1.4 was released, so there's some good stuff there. And some new way also to build and deploy a cluster. So, is this readable? Can you guys in the last row? All the way back there, 4,500 people. I only have 4 screens here. Okay, so I'm here. So I actually you cannot probably see it because it's somewhere there in the corner. I actually brought my own cloud instead of relying on hotel networks and stuff to get to some remote environment. I figured I'd bring my own cloud. So it's running right there. So it's a 4-node OpenStack cluster. And I'm logged into it here. So
Michael, what kind of hardware?
it's just some.
Is it Intel Dux?
No, it's some regular.
Raspberry Pi, right?
Some no. No, it's some I think super micro, just regular server boards with all SSD storage. So each node has 64 gigs of RAM. I think we have a total of.
x86?
Yes. Yes. No, 4 actually, but we're only using 2. Okay, talking about this cloud box. Now, so I'm logged into here. I'm actually doing this from the controller node. basically just all you have to do, you specify a few environment variables, what's the name of your stack, how many minions. So I deployed actually earlier, when we set this up over lunch, I just quickly deployed a stack. So with two, the nodes are called minions. So I have I actually have now multiple clusters running here with one controller, well, one master node and two minion nodes. Specify the external network, DNS, what flavor of VM you want, and then once the distribution, the ISO for the operating system, and then the Swift URL, because it will upload the actual Kubernetes distribution into Swift. And there's also something that I learned the hard way, very important, is that because in the documentation it only specified it to the actual port here on the Swift URL, but no, it really helps to put the authentication part in there as well. So it's the tenant ID. It's magic how stuff like that works. So just used to have, well, I just deployed this stack. And if we then go into take a look at the actual, so if you download that, you can, I don't know if, no, actually you can see it better than here than I can see on the screen. So it comes predefined for all these various environments that are supported, right? So we are using, and we're essentially running the kube-up script, which calls the respective scripts in those directories based on whatever provider we support. So if I would want to deploy right now on AWS or Azure, I would just say, this is my provider, run this script, and then I provided all the information here, and then we're good. So we can then just go to the right directory, set some other default variables, like if you do not want to, always define it through environment variables, no problem. This is one area where you can just define some defaults, like the network DNS, that always stay the same. It's one way, and then it calls this. Where's util? And then this is the script that actually gets called by the kube-up script based on the provider. The reason I'm mentioning this script is one thing I had to learn with our distribution of OpenStack is it's really key to have the respect or minimum versions, and they're defined on in the documentation on the Kubernetes website of the OpenStack command line clients, because of using the OpenStack versus the individual clients like Heat and Nova, it will fail or not. So I had to adopt this for using the individual script. And then there is some further customization that can be done. So we go further. There's the actual YAML file for Heat, and it defines all the various variables for Heat and the various options. And for example, one thing I did add, not in this one, it defines, for example, in the security group. So there are 3 security groups, one main group, which ports are going to be opened. So the API server by default listens on port 8080, and it might make sense to open port 8080 in your security group to actually get to your API server. So you can specify or further customize based on whatever you need in this script. And there are a few things that I've found that actually don't work out of the box, like the placement or finding where the actual Kubernetes distribution, the actual binaries are located. But once we have all this done, so all we really then do is just say, define the provider, and then call called a kubub script. Now, in pure Julia Child fashion, I have something prepared. Like, unfortunately, I mean, we could do this live, but unfortunately, time. It's only time. It's not that I'm not trusting. I pray to the demo gods. It's all working. Well, I did this, like I said, I did this earlier over lunch. So if I would now hit enter, it would basically go verify, hey, are all the clients installed? It uploads the both salt stack and the Kubernetes bits into Swift, then deploys. Well, it would actually pull, if not already existing, pull the CentOS images from the CentOS repositories to deploy the VMs, then checks the actual key pair, and then it goes, and you can see I actually have 3 stacks deployed on this box, and then creates the stack and goes to town, creates the master VM first, and then the 2, or whatever you specify. If you specify more, of course, it deploys more, and then deploys that. And eventually, if you did everything right and no typos and whatsoever, it will succeed, and you have a running Kubernetes cluster, and then it gives you the actual output. So in addition to the Kubernetes cluster, actually those scripts deploy some add-ons, like, for example, Heapster and Kibana and InfluxDB and Grafana for monitoring. So that you get out of the box with this installation method, you get graphical monitoring of both the nodes and the and your pods. There's a dashboard. This DNS, I mentioned that before, so for the cluster-wide name resolution of these pods, or of these containers. So that's all being deployed. Okay, so that's basically the deployment. So we now have this logged into here, into this the master node. So I can just say, get me. So now I have my 2 nodes here, so it shows me that. I can, I did this before. Basically, all these services are already running as pods, as containers in the cluster. So the DNS, the monitoring, they are deployed as containers. And they are, you can see here the namespace, so there's this, the kube system. That's where all the system stuff runs, and then there's a default. You can define your own namespaces. Right? So this is what then the pods are using to address. Now, if I want to now say, let me deploy my own container, I can just do this if I'm on the right machine.
Does it matter which version of OpenStack you're in? As long as it has heat, you're good.
Yeah. There's no. I'm not aware of any.
Anything recent, probably Kilo.
Yeah.
Anything after Kilo. Anything after Kilo. Yeah. Cole's a project.
Isn't that really cool?
And we only had a couple minutes.
Yeah. Oh, so quickly. So I have basically a JSON file here where I define my replication controller. Say, so the replication controller. I call it a name. I specify the number of replicas. And then somewhere down here, I have the actual image. And what this is, so I'm breaking with the tradition of Kubernetes demos, which is where the default container is Nginx. So I have something else where I can, where we're simulating basically fleet management, and yep. So they're both running. So I have a UI here that shows me it's not. So basically, every container that I start represents a delivery truck, a delivery vehicle, and we're just displaying this here. So I have actually 6 already running somewhere in Staccato, and I have the other one, and I can just simply then say I started 2, and the other one will show up eventually. Let's say I want more. I can just say, give me, let's say 10. And you see they're starting up, and eventually they will show, and we're getting the time check.
Yeah, it's
We're getting the time check. Okay. No rush, but we're getting the time check. So, but you see, some of them are running, some are being created, and eventually they will show up here while we do this. So quickly, in the OpenStack console, you can see obviously my instances here, but the other thing of interest is once you got logged out. And it's interesting, I told Firefox, I typically never do this, like save passwords. I told Firefox to save the password. Did a pretty good job, right? Great.
Oh, no.
That's of course happening now. But anyway, so you see the containers spun up. What I wanted to show, which, and we didn't pray to the demo gods enough, apparently. There we go. So there are my 3 stacks. So once they're deployed, and this is reacting. So, this is super fancy topology overview. So this is everything Heat basically created, right? So obviously, yes, it created the VMs that run the cluster, but it also created the network, the security groups, make sure those components are there, and then you get some output here as well. Hey, what are my nodes? What are the IP addresses? How do I actually get to the cluster? There we go. So we're getting kicked out. Yes. Stay. Questions?